Hello everybody. How are you all? I hope you all are fine and safe. Okay. So, as you all know that again I came up with a little chalk and two boards, actually blackboards. Yeah, you mean that. And before looking at me, you should have seen right over there. This is method one, so don't mind, ignore it. But let's look at this thing. This might looks, I think, for someone, for somebody, it might looks easy. That's because the derivative of this function is right over here. So what's the difficulty about this question? So I would say, yeah, you're right, but this is what disturbs the question, and what I'm gonna do, I will solve this question with two methods. That is first method over here, and the second method will try that both the two boards will just have first method and second method each. Okay, so without any kind of time wasting, just begin this. So yeah, we have I. Yes, and I'm gonna not copying this, but I'm gonna write it in a manner, and then I will tell you that what should we do next. This is, oh man, I have to change my board. Limits, we have x times arc sine of x over square root. Man, this is disturbing me. 1 minus x square, and we have dx. Now, as I think that you must have thought that what I'm gonna do next. Yep, you thought it right. I'm gonna use by parts because I cannot do instead of this. So yeah, using DI method, plus minus. I hope you're familiar with that. If not, then why I'm here, I will tell you now. Just wait. So this function is integrable very easily. I hope you can see that. That's because the derivative of this function is just sitting in the denominator. So yeah, it will be integrated very easily, and that will be in derivative differentiated. So x and sine inverse of x over square root of 1 minus x squared. Derivative of x is 1, no disturbance, and this integral is nothing but I have calculated it, and if you want me to calculate, then just tell me, I will just calculate it. But yeah, it's easy. Okay, let me just do it anyway. Sine inverse of x square root of 1 minus x squared dx. Yeah, so we have, let me just say that sine inverse of x is u sub, then the derivative of sine inverse of x is nothing but 1 over square root of 1 minus x square, right? We have du. So we have our integral as this becomes du, this thing becomes du. So we have du, and this is u, and this is u square over q plus c, and u is nothing but what? We have assumed it as sine inverse of x, and that should be squared over 2 plus c. So we have computed that thing. This is sine inverse of x whole squared over 2. Let me just erase this stuff and continue with it. Now this times this, and this should be in an integral. So our I will be looking like this: x over 2, like multiplying these two things together, sine inverse of x whole squared, and this times this, so negative 1 over 2 is taken out of the integral, and we have the integral of sine inverse of x whole squared dx. Yeah. So now the challenge to us is this thing, like this thing is just disturbing us, and otherwise, what is, if this is integrable, then just integrate it, and we would have our integral. Just to put the limit down, and you will get the answer. but we have to do with this, just because uh, without doing with this we can get the answer, so we have to do something with this. So let me just assume it as I naught. Yeah, I hope you don't mind. I hope you don't mind that. Sorry. So we have, I'm coming to this board, and sorry I cannot distribute first method and second method over here, but yeah, I will try to do that, just because my first method, the answer of my first method will be right here, and I will use that code for second method only. Okay, so I naught as the integral of sine inverse of x whole squared and dx. Okay, so again I'm doing by parts, just because after looking at it, it looks like impossible, like by doing u sub or directly. So yep, let's do this. Di method plus minus. So differentiating this function, just because it is not integrable, otherwise it was integrable, then why would I use this thing? I hope you understand that. So differentiating this thing, 2 times sine inverse of x, and this is the derivative of this thing is this, and the derivative of this inside function is inside the parenthesis is 1, yep, 1 minus x squared. And we have 1, and the integral of 1 is x. So again, this and this and this would be an integral. Let's do this, where I naught as this times this is nothing but x times sine inverse of x whole squared, right? And we have minus 2 times this, minus this times this. So minus 2 is taken out, and we have x sine inverse of x over square root of 1 minus x squared dx. And if your eyes are natural, like my this eye is slightly damaged, so if you are not unlucky like me, then you can see that this thing is the original eye. Yep. So I naught, I'm gonna just replace this integral by I, just because I can do that. I have right to do that, right? X times sine inverse of x whole squared minus 2 times I, and we have this equation right here, I as x over 2 sine inverse of x whole squared minus 1 over 2 times this thing, that is I naught. So this is x sine inverse of x whole squared minus 2i. So I think I'm gonna stuck in this thing, just because I think this method is wrong and I didn't notice it. And we have this will be multiplied with this, x over 2 sine inverse of x whole squared. So this is gonna cancel out, and we have plus I. So 2i, sorry, whoa, what? What's the purpose of doing this thing? Let me just check by like I am proving that this got cancelled out and I equals I. What is this? I was on the way to compute I, and I proved it that I equals I. What? This is ridiculous, man. I think this method is not appropriate. Okay, appropriate. Okay, yeah. Anyway, let's try the method 2. And yep, I'm just going to erase this. And I'm going to erase these two just because this method disturbed my mind. And let's try method 2 instead of method 1. Actually, this is the method. Okay, now. Anyway, like it. So what's in method 2 is I equals integral from 0 to 1 over 2. That is, I am taking x over square root of 1 minus x square in a parenthesis, and then sine inverse of x dx. Again, you can think that I'm gonna just use by parts, and this thing should be integrated, and this would be differentiated, and this is gonna work. I can see that. Anyway, let's integrate it. So we have integral, like I'm integrating this thing. I don't need to show an arrow for that. X on. Okay, so I'm gonna just use sub. So I'm gonna say that 1 minus x square is u squared. So differentiating both sides is minus 2x dx is 2u du. 2 is gonna cancel out, and we have x dx as negative u du. So we have our integral as this becomes u, and we have negative outside u du. U cancelled out, and we have negative u plus c, and negative u was what we let. U was the square root of 1 minus x square. I hope you remember that. I just erased it. I don't know why, but yeah. So u was this. U was this thing. So we have computed the integral of this function, and we will gonna use bi method plus minus, right? So differentiating sine inverse of x and integrating this thing, that is x over square root of 1 minus x squared. The derivative of this thing is nothing but the 1 over square root of 1 minus x squared, and the integral we have found, so that is negative the square root of 1 minus x squared. And now I can sorely say that this method is going to just make our life easier. Yep. So our I is this times this, and this is going to be in the bracket, in the integral. So this is negative the square root of 1 minus x squared times sine inverse of x, and minus will be positive. So we have positive integral of 1 over square root of 1 minus x squared times, it was not plus. I got heart attacks right now. 1 minus x squared dx. This is gonna cancel out, and we would get x here, and here we have negative the square root of 1 minus x squared sine inverse of x, and we have plus x, just because integral of dx is nothing but x. So we have I here. So successfully with the method 2 we have computed I, and what we are going to do next is just plug limit in that thing, that is 1 minus x squared times sine inverse of x plus x from 0 to 1 over 2. So we have negative, plug 1 over 2 here, square root of 1 minus 1 over 2, which is 1 over 4. Like squaring of 1 over 2 is 1 over 4, and that's a child's play, and times sine inverse of 1 over 2, right? And plus 1 over 2, and minus the lower limit, which is gonna plug over here, 1 minus 0 times the sine inverse of 0 plus 0. This stuff is gonna eventually 0, this because sine inverse of 0 is 0, and 0 plus 0 is 0. So it's not our fault actually. It's not our fault, and we have this thing as our answer. So let's just solve it. We have this will be 4 minus 1 roots. So sorry, this is 3 over 4. Sine inverse of 1 over 2 is nothing but pi over 6. Keep remember. And we have 1 over 2 here. So we have I as this is square root 3 over 2. Square root 3 over 2 times pi over 6 plus 1 over 2. So this is the square root of 3 times pi, square root of 3 times pi over 12 plus 1 over 12. I'm going to write it as 12, no, this is 6 over 12 to make my life easier. So, and this is negative. No, don't forget it. This is our last step. We have negative 3 times pi. Flex. Negative times the square root of 3 times pi. Oh, plus we have 6 over 12. This is our final answer, and we have successfully computed this integral. Just because I thought that method 1 will also help me out, but sometimes what you think never happens, and that's what happens with me in the first method. So that's why I use this method, and I hope you like this video. Thank you so much for watching this video. Just stay tuned for the next video. Thank you so much.